I don't want to run out of time here, but I want to use these to our advantage to be able to solve these. It says on the first one, it says find the values of the variables. So now I'm actually going to work with segments here and angles, so be very careful with what you're looking with. And most of these we're going to do angles just for time-wise. But here, I have two congruent angles. Could I call those base angles? Yeah, and if I wanted to, I could assume those two sides are congruent. That doesn't help me now, but at least that's information I do know. But if I'm solving for x and y, I should realize very quickly those are congruent. So I'm going to change that to an x for the time being. That way I can easily use the fact that the sum of the angles of a triangle add up to 180. So I just go 2x plus 110 equals 180. I subtract 110. How many? 1,180. Nice, Gregerson. All right, equals 70. X equals 35. So if x is 35 degrees, what was our original letter there? Well, that was y. Y also equals 35 degrees. Kind of common sense. Now, don't let the next one confuse you. It actually should be a very quick, easy problem. Notice, again, I have an isosceles triangle. You should know what the legs are, the vertex angle is, the base angle, and the bases are. Every single time you look at this, notice they bisect the vertex angle, the top angle where the two legs make it, which means this segment is a perpendicular bisector. So that means y right away is 90 degrees. Now if that's the case, if this segment's 10, that makes this one over here 10. So can I go 10 plus 90 plus x equals 180? Yeah. So x would actually end up being 80 degrees because 10 plus 90 is 100. Subtract that from 180, it's 80 degrees. Not too bad. Now, wanting to use this to your advantage, how in the world am I going to do problem number 3? It's kind of meant to be a harder problem. Well, use the fact what you know about triangles. For instance, here I have an equilateral triangle, which means I know all the angles are the same, because if it's equilateral, then it's equiangular, which means this angle is 60 degrees and this angle is 60 degrees. Okay, great. I also know I have 4 congruent sides and a right angle for this quadrilateral, which means it has to be a square. Now, how in the world am I going to solve for t, which is on this outside? Well, remember, if I go around a single point, how many degrees is that? 360, right? Especially if I divided it with a line segment, we know that's 360 degrees all the way around. So can I use the fact that all 4 of these angles add up to 360? Yeah. So I can go 60 plus 60 plus 90 plus t equals 360 degrees. So 60 plus 60 is 120. 120 plus 90 is 210. So I get 210 plus t equals 360 degrees. Subtract 210. T is going to be equal to 150 degrees. Not difficult, but you notice I marked up the diagram with everything that I knew. Now let's look at number 4. Now in number 4, I hope you realize there's 3 different triangles there. And this one's going to be an isosceles triangle. If I have an isosceles triangle, shouldn't I be able to figure out its angle measurements? Yeah, because I know the base angles are going to be the same. Now I'm looking at the big triangles. That means this one had to be R. Well, can I use the big triangle to help me out? There's nothing saying I can't use the large one. I know then that 2R plus 90 equals 180 degrees. So 2R is equal to 90, because I subtracted 90 from both sides, and R would equal 45. So that's 45 degrees. That means over here, don't like doing it with the arrow, but we're going to have to this time for space. That one's 45 degrees. Now, look at the small triangle there. That small triangle, and I'm seeing if I can find a green pen, and I can't find one real quick. If you noticed, is also isosceles. That means its base angles are going to be congruent too. So that means right here, if I go opposite those angles, that's also 45 degrees. So S is 45 degrees. Marking up the diagram was critical on this one. Let's do the next one together. Again, I have drawn an isosceles triangle. if I know the legs are congruent, what do I know about the base angles? The base angles are congruent. You're right. So that would be x degrees right there. Now, again, start using what we know. Does anyone see a linear pair? Yeah, me too. So I go x plus 125 is equal to 180. X is going to equal 55 degrees. I'm going to subtract 125 from both. All right, so that means this one's 55 degrees. This angle is 55 degrees, which means I now can solve for y fairly quickly. Y is just going to be y plus 55 equals 180. So y plus 110 equals 180. Y is equal to 70 degrees. Great. Now, how do I find z? You could do it two different ways. You could do here, if you wanted to mark that, the two remote interior angles add up to the exterior, or could I just use that's a linear pair? I'd probably use that as a linear pair. So we can go z equals 180 minus 55, which is 125 degrees. So you guys could easily do those. All right, now, looking at number 7, there should be no problem for you guys to get this, okay? I'm looking at this, I see an isosceles triangle. I'm looking for segment lengths, okay? Don't freak out, but when I have segment lengths, I should know that they're equal to each other. So I can go 2x minus 6 is equal to x. I'm going to add the 6 over, equals x plus 6, and then I'm going to subtract x from both sides. X is going to equal to a positive 6. Now, this is just some of the stuff we're doing. I can't get all of these done, so I know you're probably going to go crazy with me doing this stuff. But I do want you to understand how this all works, okay? Like number 8. Here I have 3 triangles with 2 pairs of congruent sides. So it basically means I know these 2 sides are congruent, those 2 sides are congruent with those 2 sides. So I have all these isosceles triangles. So that means if I know these 2 angles, I basically can solve for B and A. All right, so let's go ahead and use that fact. If these 2 are the same as these 2, what do I know about B? It's 30. What do I know about A? It's 30. Why? Because I've used up 2 of the same angles for each triangle, so I have the same amount left over. So A and B are both 30 degrees. Well, that means how do I solve for C? Well, those are the same size. So I can go 30 plus C equals 180. So 30 plus 2C equals 180 degrees. So 2C equals 150, C equals 75 degrees. So those would be our values. All right, guys, I hope this gives you a good start. It doesn't answer every question, but I hope we get going well on it.